Okay, good morning, good afternoon, everybody. We'll make a start over 600 people in attendance. So thank you all for taking the time today to come to this webinar. I just want to give a little background about CIBSE, and then I'll hand over to Simon, who'll be talking about net zero. So CIBSE certification, we've been around for 15 years. We originally started in the personal certification industry, so we assess and ensure that energy sectors are competent, and obviously that produce certificates in EPCs, DECs, things like that. And when we moved on to, in the last 4 or 5 years, we've moved on to certifying management systems within organizations, including 9, 14, 45, and 50. And I'm sure that for those of you working in the building service industry, you'll be aware of the ISO 99001, which will be coming out soon, which is tailored to the built environment. But as I say, every webinar, if you are running a management system in your business and you're interested in us being your preferred certification body, you can drop us an email at the email address below. But for now, I will hand over to Simon, who will be presenting on net zero challenges and opportunities. Do drop your questions in the box if you have any, and at the end of this presentation, we'll go through them.
Okay, hopefully you're seeing my screen now. Let me know if you're not. Okay, so good afternoon, everyone. My name's Simon Wyatt. I'm a partner at Cundall Engineering Consultancy, but I'm also the chair of the CIBSE Knowledge Generation Panel, which means I spend a lot of time looking at our existing knowledge, but also helping generate and highlight where we need new knowledge. And over the last couple of years, CIBSE have generated more knowledge than we have over the last decade. So CIBSE is continuing to put out good quality knowledge for our members, and a large focus of that over the last few years has been around net zero carbon. So I'll share some of the stuff that CIBSE have been doing, but also the wider industry in terms of net zero carbon. So what I'm going to be going through today, I'll just do a little bit of context, why we're all talking about net zero carbon, go through what we mean by net zero carbon for buildings, and that's kind of generally broken into 2 areas, which is whole life and embodied carbon and operational energy. Both are important to building services engineers. We've probably focused much more on operational energy over the last few decades, but embodied carbon has risen up the agenda over the last few years. Also touch on existing buildings, because most of the standards and most of us have been focusing again for the last few years on new buildings, but 90% or 80 to 90% of buildings that will be operational in 2050 have already been built, and we need to get those to net zero carbon as well. So there's a big challenge associated with that. And then I'll finish up with some insights into what's up and coming in the net zero carbon buildings field, including the new RICS guidance, which is due out in a few months' time, and then the net zero carbon verification standard, which is an ongoing project, which I'll touch on towards the end of the presentation. So just to give a bit of context, why are we talking about net zero carbon? Well, a couple of years ago in Glasgow, the world came together at COP26 to review our global commitments and targets, and even with the most optimistic scenarios, we're still significantly above the 1.5 target we've set ourselves in terms of limiting climate change, with the actual policies indicating we're actually probably closer to 2.7 degrees of change. So although we continuously talk about reductions and meeting the aspirations of the Paris Agreement, we are still a long way away from achieving it. And there are a number of websites and organizations which track individual countries' performance. And as you can see from the globe, which is shown on the screen here, most countries are either critically insufficient or highly insufficient in terms of their policies. There's very few countries which are aligned to the Paris Agreement. I think it's 2 at the moment. And there's a number which are almost sufficient, but still have a long way to go in order to meet those targets. When we look at the UK, it's an interesting scenario. We generally are doing better than most in terms of policy and where we actually sit. So the UK were one of the first governments in the world to declare a climate emergency and set a net zero carbon target by 2050. We did this back in 2019. We've since strengthened that because we know that being net zero carbon by 2050 won't be enough. It's the scale and speed of reduction which is important. So we've set interim targets of 78% by 2035 and 68% by 2030, and that's really important if we want to align to the 1.5 degree Paris Agreement. That still leaves the UK insufficient and not aligned to the Paris Agreement, and this is purely based on policies, not action. So the policies we've got will potentially enable us to get there, but it's still not fully aligned, and we need the action to follow up the policy. And what's really important is to look at it by sector. So last year, the Committee for Climate Change issued a document to the government which indicated where they were on track and where they weren't on track in terms of meeting their requirements. So you can see in terms of the energy, electricity supplies and surface transport, there's credible plans, some risk associated with that, but they generally have a strategy of getting close to where they need to get to, not fully, but close. Whereas you can see the ones that we're generally interested in, which is buildings and construction, there's almost no strategy. There's significant risk and insufficient plans in order to get there. So there's limited action and limited policy in the area of the built environment, which we need to really address. So what are we seeing in terms of how that is being addressed at the moment? There's been obviously a significant move over the last couple of years towards net zero carbon. Everyone's kind of talking about it. Most projects will have a net zero carbon agenda. And that's mostly not being driven by government. That's generally being driven by the private market. We're seeing demand from occupiers who are setting their own science-based targets and setting aspirations to be net zero carbon and demanding that of the buildings they're occupying. We're seeing most of the UK developers sign up to the World Green Building or the Better Buildings Partnership commitments to net zero carbon and are working through their pathways and trajectories. And that's being passed on to design teams for both new and existing projects. But the biggest driver we've seen over the last 2 years has definitely been from the investment community. Lots of funds and large portfolio asset managers are reporting to TCFD, the Task Force for Climate-Related Disclosure, reporting to GRESB, reporting their climate emissions, and are marketing their funds as green funds and are passing those requirements down to developers who are then passing them down to their design teams. So there's a huge drive at the moment from the investment community in terms of compliance with net zero carbon. And one of the ways that they are doing that is via CREM, which is a basically decarbonisation pathway for existing real estate. And what this basically does is it looks at the carbon emissions or energy intensity of any building in the world. So you can select an office building in Berlin, a factory in Mexico, and what it will do, it will give you a energy target from now to 2050, which is on a sliding scale, so aligning to a 1.5 degree trajectory. And what large portfolio owners are doing is they're looking at their individual assets, understanding the current performance. If it's below the green line, that's good, it's performing well. But you can see here that if this asset, which is below the green line now, doesn't do any works, continues operating at the same level for the next 10 years, then it will cross over that green line and be above its fair share according to the Paris Agreement. That is known as a stranding event, and what lots of pension funds and investors are doing is they're trying to understand when their assets will strand and either move those assets on if they're going to strand immediately or do works to those assets in order to do improvement. So lots of net zero carbon assets and audits in order to move those assets down more aligned to the Paris Agreement 1.5 degree targets. So that is driving a huge element of the built environment in terms of why we're doing net zero carbon. In terms of definition, there's been a lot of documentation published over the last few years from UK GBC, LETI, CIBSE, and other organisations, and we're generally getting to a unified definition. The Whole Life Carbon Network last year published a unified definition for net zero carbon, which has been endorsed now by iStructE, CIBSE, RICS, RIBA, and pretty much all of the built environment. So they're kind of unified definitions now, which we're going to be taking forward, and they've been written into the new RICS guidance and will be used for the net zero carbon verification standards. And what's important to understand is really the difference between net zero carbon and carbon neutral. Carbon neutral has been a term we've banded around for over a decade, probably 2 decades. And that simply is that you work out your carbon emissions and then you have removals which equal your emissions. So you can buy offsets which equal your emissions. There's normally a requirement to have a reduction plan, but there's no minimum standard you must meet in the first place. As long as you remove your emissions, you can claim to be carbon neutral. That's kind of lost a lot of credibility over the last few years with the unreliability of offsets and the idea of paying someone else to do your work, basically. So where we've kind of moved towards is net zero carbon. And net zero carbon basically means that before you go to removals, you have to hit minimum performance targets which align to a 1.5 degree scenario. So your emissions have to be capped in alignment with 1.5 degree. And then you can choose to go to the net by doing removals. But in theory, just doing the emissions reduction in alignment with 1.5 degrees is enough to align with the Paris Agreement. The removals are a final added extra step. There are also a number of people talking about absolute zero, and there's actually a number of developers who've actually committed to absolute zero, but again, there's no details of how they're going to achieve it, whereas the UK GBC, Bear Building Partnership, all their definitions are around net zero carbon, and that's what most developers are working to at the moment. And again, when we talk about net zero carbon in the built environment, we're generally breaking that into 2 different elements. We're talking about net zero carbon in operation, so that's generally operational energy, also including refrigerants and off-gassing, which is becoming more and more important as we reduce energy consumption. There's also net zero carbon on construction, which looks at the embodied carbon in materials. And again, that's been more of a focus of structures, architecture and facades, but again, the importance of building services can't be underestimated. What we've found over the last few years is building services generally been underestimated in terms of their amount of embodied carbon, and you have to remember that building services are generally replaced much more regularly than things like facades or structures, which generally have at least a 60-year lifespan, whereas services is generally 20-25 years, so we'll have a much more regular replacement cycle. So just starting with embodied carbon, again, the last 10 years, we've seen a much bigger focus on it, starting with the introduction of the life cycle modules from the European Union. The RICS professional standard was published in 2017, which was a major game changer. So the construction industry had a unified way of calculating. That's just being updated at the moment and will be released later this year. Again, LETI have produced a number of guidance documents, including their embodied carbon primer, and CIBSE 2021, published TM65, which is the first methodology in the world for calculating embodied carbon in building services. And hopefully a number of you have been working towards that and are using that on projects. The next step will be to get embodied carbon into building regulations, like Part L regulates energy efficiency. Part Z is a proposed guide which will make it mandatory requirement for all developments to do embodied carbon calculations. There's a strong lobbying group trying to get that through Parliament at the moment. So when we look at embodied carbon, we generally, as I said, use the RICS methodology, which breaks embodied carbon into a number of areas. We generally, if we want to simplify this, we generally talk about upfront embodied carbon, which is the carbon that the building requires to be built up to practical completion. And then we talk about whole life carbon, which considers the in-use, repair, maintenance, refurbishment, eventual demolition, and then hopefully reuse of some materials as part of the circular economy. Whenever doing any assessment, the main focus is setting targets around the upfront embodied carbon, because that can be much more accurately calculated, and the climate emergency is now, so we need to understand what that embodied carbon is and limit that as much as possible, whilst making consideration of why we're doing things based on whole life carbon. A good example is facades. If you're looking at a building, if it has a facade system which is low embodied carbon but has to be replaced after 30 years, it might be more beneficial to go for a slightly more intensive upfront embodied carbon, but it's got a 60-year life. So again, it's making those trade-offs between upfront embodied carbon and whole life embodied carbon. As I said, the number of organisations, especially LETI, have been setting a number of targets around embodied carbon. So there's embodied carbon targets, both upfront and whole life embodied carbon for a variety of buildings, offices, residential, education, retail. They are for the whole building, but what's broken down in those documentation is sub-targets. So what any project should do, if you're building a commercial office, you have a target of 600, there should be a target of probably 300 for the structure, 100 for the facade, and then 100 for services. So it's understanding the budget for your element of works and then trying to lower that as much as possible. And as I said, in terms of building services, what we should be doing is using the new CIBSE TM65 methodology to accurately or fairly accurately predict the embodied carbon. More and more manufacturers are publicizing their embodied carbon data. Ideally, that would be EPD certified data, but again, a lot of them are only just starting to go through the process. And the problem we generally have in building services is we have very complex supply chains. If you think about structures, you've generally probably got a steel beam, which has been mined and then fabricated in one factory. It's a very simple process. Whereas if you're looking at something like an AHU, you might have 1,000 components coming from all over the world, and depending where those components are manufactured, will have different carbon emissions. Their transportation to be assembled will have different emissions. Pulling all of that information together is quite onerous for supply chain. Manufacturers are doing that, and again, if you can specify performance requirements for different equipment, that's really useful. And again, getting them to upload their data onto CIBSE's website is really valuable, because then we have a much better database that all consultants can use going forward to kind of benchmark projects and use default values. And what we're seeing is more and more of a requirement in terms of planning for embodied carbon. So whenever looking at a new project, there will be a requirement as part of the planning application to do embodied carbon assessments, looking at different structural solutions, different facade solutions, looking at things like hybrid structures, which are CLT flooring with steel members, looking at full steel structures, or even looking at full timber, and comparing them against benchmarks like the GLA benchmark, which is part of the planning application. And what's interesting is we're starting to see a requirement to not only look at the embodied carbon, but also bring in the operational carbon, so bringing in the operation energy. And as you can see from this graph, what's very interesting is how we take a 60-year life of a building. If we use the current grid emissions factors, operation energy is the significant part. It's at least half the energy, half the carbon of a new building. But if we use the national grid decarbonisation strategies, then the operation energy becomes less and less important. And you can see here that in some instances it could be less than kind of 5 to 10% of the emissions of a building over its life. So that upfront is really important. But what you should be doing is reporting both grid decarbonised numbers and non-decarbonised numbers to kind of show the uncertainty and risk associated with some of those decisions when going through the planning process, so that they can understand the implications of either doing nothing like refurbishment or a full new building. And again, one of the things which is rising in importance is the Retrofit First campaign from the Architects Journal. You've probably seen in the media there's been a bit of backlash against demolition and rebuild. So again, justifying any works is really important in planning. And again, we should have a focus on reusing as much as possible, whether that's the entire building or just saving the structure. Structure is generally 50% of the upfront emissions of a new building. So if we can take a building back to structure, reclad with an energy efficient facade, that you're going to be half in the carbon associated with it, whilst being able to get down to the energy performance requirements we kind of need for new buildings. So moving on to operational energy. Operational energy is generally where we focused as building services for the last couple of decades, as I said. And this is the definition which has been generated by the Whole Life Carbon Network for a net zero carbon operational energy asset, which is where no fossil fuels are used for the heating and hot water, where it meets local energy targets, and all energy is generated on or off-site from renewables, which demonstrate additionality. So really what we're looking to do is move away from natural gas heating or fossil fuel heating, electrify, and then reduce that energy consumption in line with targets. And then once that's done in use, it's about providing renewables. So if you're building a 2-story building out in a country park, there's no reason why you probably can't generate enough energy to be self-sufficient. Whereas if you're building a 10-story building in an urban environment, you won't be able to have the roof space available to do that. So a proportion should be generated on site, the rest coming from power purchase and renewable tariffs, depending which country you're in and how that's managed. We also will always have some residual associated with backup diesel generators, refrigerants, leakage, so they need to be also reported and understood. And as we decarbonise the grid, refrigeration is likely to become a much more significant element of what we're doing going forward. One of the biggest challenges will always be, what are the operational energy targets we're setting? So the UK Green Building Council did an exercise a few years ago where they looked at how much renewable energy we can generate in the UK, bringing online the proposed schemes, a lot of offshore wind, and then saying how much would we be able to meet of the UK supply. And we wouldn't be able to meet all of the UK supply. So at the same time as generating more renewable, we need to reduce demand on the grid. That needs to come across all sectors. And if all sectors reduce their energy consumption equally, that would probably equate to about a 60% reduction in energy demand in order to be 100% net zero carbon from our energy supplies, which is where the national grid are aiming to go. So again, that decarb strategy we were talking about earlier is dependent on the ability for the national grid to decarb, which is dependent on energy efficiency and a reduction in demand on the grid. So if we just take a 60% reduction for all buildings across the board, we can start generating what we call Paris-proof targets for different building sectors. And this is what the UK Green Building Council and LETI have done. If we take commercial offices, you can see here, based on the energy efficient REED benchmarks, you've got a 50 percentile office here, which has energy consumption about 300 kilowatt hours per meter squared. Top 25 percentile, just under 200, whereas the LETI UK GBC target is down at kind of 70. So it's a significant reduction. It's not about small steps changes. It needs to be wholesale change to the way we design and operate buildings. So we know what the targets are. The question is really, how do we meet those targets and how do we kind of measure those targets? One of the ways we've always assessed energy consumption in the built environment has been EPCs. We know that EPCs aren't fit for purpose. You can see from this diagram, which has been used extensively over the last couple of years, is there's no correlation between the actual energy performance of a building and its EPC rating. This is because EPCs are very simplistic. They're very much focused on energy efficiency. They don't look at energy consumption. They're generally standardized profiles and only look at regulated loads, not a whole building load, looking at process loads and systems as well. So again, EPC is not a measure of operation energy. It's a good guide of energy efficiency, but that is all it should be used for. What's kind of been brought up to kind of bridge the gap is the UK Green Building Council for offices have put together a step trajectory showing whole building and base building energy consumption targets. So base building would be the landlord systems. The whole building would also include small power and tenant systems being used. This approach is being used across multiple sectors, but the only targets at the moment are for office buildings. And it has, you can see, a step trajectory showing targets from 2020 to 2025, 2025 to 30, 35 to 35, and then the final Paris-proof targets. This is an interesting approach. So a lot of new buildings are looking at these step trajectories. And if you see on social media, on LinkedIn and other places, news articles, that buildings are claiming to be net zero carbon, with almost certainty they'll be looking at the interim targets. They won't be looking at the Paris-proof targets. There are very few if any, that are actually meeting the Paris Proof targets. So they have a time stamp which basically says they're net zero carbon for a period, but once they go past that period, they will no longer be aligned with the net zero carbon aspirations and will need to do remedial works. So what you really should be doing with any project is kind of pushing as far along those steps as possible in order to align with the Paris Agreement and not have to do extensive works in the future. In the commercial office sector, there's also been the introduction of the UK Neighbours, which is a rating system which only looks at the base building, so only looks at landlord systems, and I'll go through that in a bit more detail in a minute. And then it gives a star rating from 1 star to 6 star, with 6 star roughly being equated to net zero carbon. And again, in the UK at the moment, the best new buildings are coming in at 5.5 stars. So you can see they're hitting that interim step. None have got to that 6 star level yet. When we talk about operation energy, we're talking about actual energy consumption. So this is metered energy consumption. So we should be taking the metered gas, electricity readings, and then comparing the energy consumption per square meter of a building. That will tell you whether the building is net zero carbon in operation. Obviously, when we're doing new building or retrofit work, we don't have that data. We're doing design work. Therefore, we need to predict and make estimates of the operation energy. That needs to be done using simulation methodologies, and the ones that we recommend using are for commercial offices, things like Neighbours, Design for Performance. For heat-led buildings like residential, leisure centres, hotels, passive houses are proven technology for achieving performance in use. And also CIBSE TM54, which was updated last year, is a great methodology for assessing simple buildings and complex buildings. It can do a simple Excel spreadsheet-based approach, or it can do a full HVAC approach using IES systems or task systems. So it's a very good tool for operational energy prediction. But remember, they're only predictions. The final rating or performance is verified in use with using 12 months of real data. What it's not, and again, what we're not wanting people to be doing is talking about Part L and EPCs. Again, they have their place and are useful, but they will not give an indication of how a building is actually performing or likely to actually perform in terms of its actual operation energy. And again, just coming back to those CREM trajectories we were talking about earlier and interim steps. So again, if you build a building and on day one, you're on your net zero carbon, you're aligning with CREM, you're still going to have a stranding point. And what you should be doing with any new development is trying to push that stranding point out as far as possible. So again, if a client is saying, I want a net zero carbon building, you need to basically explain to them that if they hit an interim target, it will be net zero carbon, but it will have a timestamp. It will be net zero carbon till 2030 or 2035, after which period they'd need to do works to maintain that net zero carbon status. And again, when technical due diligence is being done on that building by the professional team, they will highlight that stranding risk, and that will affect the valuation of the building going forward. And one of the things we generally see around net zero carbon is a lot of articles on the cost of going to net zero carbon. Obviously, generally there is an element of cost associated with it. Most of that can be limited, and it's understanding what is the true cost. We've heard figures from kind of a couple of percent up to kind of 20%. Again, if it's well designed, there's no reason why that can't be closer to kind of 5% uplift. You're generally going for thicker insulation, more insulation, going for more controls, more zonability, which all add marginal cost to a project. But what you have to remember is if you spend that cost on day one, it's probably a 5% uplift. If you don't spend that cost and the building achieves a worse energy performance, again, it will strand earlier, and there will be a requirement to do retrofit works. And obviously going back to a building which was built 10 or 20 years ago and having to improve the insulation and cladding or changing out boilers for heat pumps is obviously going to be much more expensive as a retrofit option than a new build option. So again, as well as doing whole life carbon assessments, we should be doing whole life costing exercises to demonstrate the value of doing these works on day one, rather than paying considerably more over the life of the building to do piecemeal retrofit. So just looking at a case study. So this is Eden, which is a project in Manchester, which is just due for completion in the next few months. It was designed to BREEAM Outstanding, but also was one of the pioneering projects for Neighbours UK. It has done a design for performance assessment, indicating it's getting to a 5.5 star Neighbours rating, which is the highest rating in the UK. There's a couple of buildings at 5.5 star, none at 6. The key thing to remember with Neighbours is there are two schemes for Neighbours. There's Neighbours Energy and Neighbours Design for Performance. Energy is the important one. That's looking at the real energy data. So you need 12 months worth of bills, you need your hours of operation and your leased areas. Once you've got that, you can input that into the Neighbours calculators, which will give you a Neighbours energy rating. And again, this is going to be really important over the next few years in order to compare buildings, leased buildings, and the valuation of those buildings. In the absence of that, for a new building, what we do is, as I said, Neighbours Design for Performance. Neighbours Design for Performance and Neighbours Energy look at the base building, as I said. Base building is generally the whole building HVAC systems, lifts, common area lighting and power, and domestic hot water. What it excludes is occupier, lighting, and small power loadings. They should be added to the total for the whole building analysis, but for Neighbours, we just really care about that base building performance. And again, what it means is that as a design team, we can focus on the base building because that's what we have control over, and then we can leave the occupier with their fair share in order to look at their ICT and operating parameters as they go forward. Design for Performance has a very defined process, which is basically signing up to an agreement, doing detailed modeling with off-axis scenarios. So an off-axis scenario would be modeling different variations, so using future climate weather, for example, looking at different occupancy patterns and profiles, saying what if, running different scenarios to see what impact that would have. The reason you do that isn't to get a range of results, it's to see what the impact would be on your energy performance so you can understand the risk of those scenarios and then take mitigation measures to kind of reduce that. What's important with Neighbours is that once you've done the modelling, it needs to go through an IDR process, independent design review, where a panel of experts will review the project, make recommendations on the design, the simulation, the controls, commissioning, and the operation of the building in order to maintain that rating and verify whether they think you actually can achieve the rating you've targeted. Once you've got that, you can market the building as Neighbours Design for Performance rated, and then there is a commitment to change that to a Neighbours Energy rating once you have the 12 months worth of data. What's really important to understand with the IDR and modelling is the modelling is based on a set of assumptions and scenarios. It's not a prediction of the future. If you're predicting the energy consumption for the base building is 40 or 45 kilowatt hours per metre squared, that's based on the assumptions. What the IDR process will do is highlight where things can go wrong. Like if you have a mixed mode ventilation strategy, for example, and you haven't looked at how you're going to control the windows, that's a significant risk of increasing the amount of energy consumption you're going to have. Also looking at how you manage out of hours usage. If you have no way of controlling the hours that occupiers are using the building, that will significantly push the energy up. So again, it's highlighting where you need to focus the attention going forward, highlight the risks of various commissioning controls elements. So the IDR will basically say whether the modelling is fine for that scenario, but it's not saying that will be the performance of the building. It's saying the building can perform if it's operated in a certain way, and the future will vary massively depending on how that's controlled, and that will ultimately give the Neighbours energy rating, which is the important one. So as I said, Eden had done a detailed operation energy assessment at early stages. It's an all-electric building, near passive house energy performance, heat pumps, CO2 heat pumps for the domestic hot water, reduced set points, very efficient design, and that was coming in at 5.5 star Neighbours. But what you can see here is that the net zero carbon target for the UK GBC has 35 as a target for the base building and 35 for the occupier. Eden is coming in just over that 35, just below 40, and with a range of scenarios. But we have almost no confidence the occupier can get down to that 35. So although the base building is 5.5 star, close to 6 star, the actual whole building is significantly above the UK GBC LETI target still. And this is really important to understand, and there's a lot of occupiers out there at the moment who are looking to rent 5.5 star, 5-star buildings, thinking that is enough to meet their net zero carbon aspirations. But you have to remember that energy is broken into kind of two areas. We've got the base building, which design teams are looking to reduce using the neighbours rating, but it also depends on how much energy is used by the occupier. And if an occupier goes in there and works as they have been for the last decade, they will significantly blow their occupier budget. So again, where you're looking at kind of speculative office type buildings, you should be working with the base build team to get that as low as possible, but then also working with the fit out team and the actual organization to look at their operations and their performance. Where you've got owner occupiers, you're going to be looking at those combined, but it's always worth breaking them into two so you can have a look at the performance. Just moving on finally to existing buildings. As I indicated, 80 to 90% of buildings in 2050 already built. We have to decarbonise all of them to meet our net zero carbon aspirations. So that's 28 million private homes and 1.7 million non-domestic buildings in the UK need to go through a retrofit programme within the next 25 years. So that's a huge amount of work, which the built environment and our industry can't currently comprehend or deliver. So we need to upscale in order to meet the challenge that we're being faced. And one of the biggest challenges we obviously face in the UK is the decarbonisation of heat. Most private homes use natural gas, so we need to move off that natural gas onto alternative sources. The main focus from the Committee for Climate Change is obviously air source heat pumps at the moment, or heat pumps ground source potentially, but the main focus is definitely electrification away from natural gas, which is going to be a huge and significant challenge, both for the built environment, but also for the energy sector. So what we're seeing a lot of at the moment is large landlords, developers, funds are looking to decarbonise large portfolios. So a number of portfolios could be a few hundred assets. There are clients who have thousands of assets in the UK, and there are super clients who have millions of assets globally, and they're looking to decarbonise all of them. So they need to go into each asset and produce a net zero carbon improvement plan, looking at what we call the steps to net zero carbon. So looking at passive design, operation energy, removing fossil fuels, renewable energy, but also whilst considering upfront embodied carbon, whole life performance, and then having a reporting structure. So what we need to do is understand the current performance of an asset and understand what the target is. And once we understand the target, then we can start going in and looking at individual interventions in order to move the existing asset from where it currently sits down to that net zero carbon target. And that will be through heat pumps, electrification, fabric improvements, potential to move to mixed mode and natural ventilation. But there's also a significant requirement for things like behaviour change. And the problem with existing buildings is you generally don't get the opportunity to go in and do all of those simultaneously. They normally have tenants, plant replacement schedules, and that needs to all be factored in to the life of the building. So if you have a sitting tenant who's got a 20-year lease, you're going to struggle to get that building to be net zero carbon by 2030 if that's your target, or even 2040 if that's your target. So it really needs to be programmed into the life operations of that building. So that's kind of the end of my main presentation. I just wanted to finish up on a slide before we go to questions on the new RIC standard, which is due for publication later this month. As I said, it's been updated, and one of the main areas which has been updated is B6 and B7, which is operational energy and operational water. So there's much clearer guidance now on how to calculate and report operational energy and operational water. But the biggest thing which is going to hit the industry, hopefully later this year, potentially next year, will be the net zero carbon verification standard. This is a cross-industry collaboration with CIBSE, the Carbon Trusts, iStruct, RICS, RIBA, LETI, UK GBC Better Building Partnership. At the moment, they are looking at the processes to verify both embodied carbon and operational energy. And one of the key areas they're looking at is sectors. So as I said earlier, we already have a few targets for commercial offices, schools, residential, retail. what the net zero carbon verification standard is doing is it's looking at a multitude of sectors and a multitude of subsectors. So I'm personally involved in the life science group, and we have targets for about 8 or 9 different subsector of life science. Light industrial, similarly, will have multiple targets and sub-targets depending on the usage and area of the building. So we're going to get a whole range of targets. There's still a lot up for debate. So the question is whether there's step trajectories or just an end Paris-proof target. There's also the debate around whether there's base build targets and whole building targets. All of them are being debated at the moment within the net zero carbon standard, and will hopefully be resolved by the end of the year with a clear methodology and process for verifying that. And one of the things that I'm very keen to be done is that CIBSE becomes the home of the verification of operational energy. So that will be operational energy assessments like DECs for existing buildings using real data, but also a design check to see if a building is net zero carbon ready or enabled based on its TM54 or passive house calculations predicting the energy consumption, and then verifying that prediction in order to be certified as net zero carbon enabled. So CIBSE are working through that at the moment, and hopefully we'll give an update on that over the next few months. Right, that's the end of the presentation. Have we had any questions?
Thanks, Simon. Yeah, we've had quite a few. I'll start from the top. You answered this in your presentation, but if you can just give us a 30-second overview. What's your view on the difference between net zero and carbon neutral?
Yeah, it's been a big debate. And again, if you have a look at the true definition from the UK government, it's net zero carbon is still fairly woolly. So what we did in the Whole Life Carbon Network, which is a group of professionals, mostly around embodied carbon, we looked to set a new definition for the built environment, and that's the definition I showed you earlier, which is net zero carbon has to align to the Paris Agreement before you offset. So there's absolute reduction requirements. And again, if you look at the definitions for both embodied carbon and operational energy, they will both have a requirement to hit a limit before you offset embodied carbon or you go to renewable energy for operational energy. So it's very much having that hard target, because over the last decade we've seen a multitude of organizations offset their emissions and claim to be carbon neutral, which is good. They've done a good thing, but it's no means the end. Offsetting is the last resort or last part of a puzzle, which really should start with energy efficiency and reduction.
Perfect, thank you. I've got a bit of a long one, but I'll ask it. It is hard to believe that the UK is deemed almost sufficient. In continental Europe, it is becoming the norm for new builds to install rainwater collection tanks, to comply with very strict insulation norms, to have heat pumps and solar installed. These things are not all driven in the UK. Why?
Again, as I said, the first, I think it was the third slide I showed the gap. The UK is, as a government, has very much focused on the energy sector and surface transport. So they've met a lot of the requirements from shifting to North Sea gas from coal. And then the next phase is to electrification of grid and renewables. The built environment has almost no strategy. As I said, most of that is being driven by the investment community. There's a massive gap where legislation needs to be from central government. There's a number of bills that have been done. So the select committee commissioned a review of the built environment, and a number of recommendations were put forward, led by Simon Sturgis. It's very good what his recommendations are. Whether those get adopted by the government is questionable. Planners are driving probably harder than central government, and again that varies massively. So if you build in London or Cambridge, all those things you mentioned earlier would be a mandatory requirement. The problem is there's an inconsistency. Most local authorities are under resourced and therefore struggle to implement a number of these things. The government have improved the building regulations to require more regulation in terms of insulation, but they don't go anywhere near far enough. The Scottish government have looked to mandate passive house, which is a great step in terms of insulation, but there's no requirement for PV. So there's huge scandals in terms of lack of joined up thinking. But I've come to the conclusion personally, and I think a lot in the industry have, is that we can't wait for government. Government are way behind where they need to be. There's been too much distraction with Brexit, COVID, internal squabbling, that they're not focused at all on decarbonisation. Therefore, the industry needs to do this. This is why the net zero carbon verification standard is being proposed, and the investment community seems to be finally waking up to it and driving it a lot harder than central government. So I completely agree with your comment. The government needs to do a lot more. There are people lobbying for it, but don't wait for them to do so.
Great, thank you. Just talking about the stranded assets, how is the stranded assets decarbonisation checked? Is this self-declared or have some form of check?
It's an interesting one. So I've spoken to a lot of developers and they've said, well, is this mandatory? And it's like, no, this isn't mandatory. But the issue is that a lot of funds are looking to have green investments. They're looking to meet ESG requirements. At the moment, most of them are self-proclaimed. There's some basic requirements in order for them to meet them, but there's quite a lot going on in green finance to regulate this. And once there is regulation, in order to have a green fund, you have to meet these requirements. And what I've seen over the last couple of years is the big institutional investors are really taking this seriously. So they're going through their entire portfolio. Any assets which are really poor performing, they're dumping to get rid of before they start to devalue. And where we're doing technical due diligence, we're going into new buildings and saying, well, we need to reclad it. You put a gas boiler in, we need to replace the boiler. Therefore, we're going to take this off the valuation. So it's the value of that asset which is going to be effective. So at the moment, yes, it's very much self-certifying, self-performance. But if you're not looking at the decarbonisation pathway, then you're devaluing your asset. I've seen developers now put together decarbonisation pathways and include that in their sales information. So they're saying, we haven't decarbonised the building, but we've done an assessment and this is the pathway to get to align to CRREM or science-based targets. So it's really trying to maintain that value. And what we've seen with the slight challenges we're seeing in the market at the moment is there's a lot of developments being stopped, but what we're seeing is the ones with high ESG credentials are going forward, and there's a number of schemes which have demonstrated a higher return for those ESG credentials. So again, finance is driving a lot of this in terms of the decision making and where we'll go and the direction of travel.
Perfect, thanks, Simon. Just staying on this topic, 2 questions. Where does the stranding graph come from, and is it the same for all types of buildings or building specific? And what would a building system look like now to avoid stranding?
So the stranding tool that I was showing you there is CRREM. It's not the only one. There's multiple ways of doing it. So I work with a number of clients who use the Science-Based Target Initiative, and then they apply that to their own real estate, so they have their own bespoke trajectories. But the CRREM tool was set up by a number of the European investment banks, and that is basically looking at benchmarks for current performance and then setting trajectories. So you can go onto the tool, it's freely downloadable from the website, and you can basically select any type of building. So you can select hotel, office, student accommodation, and then you can select a country, and it will give you the current target, and then it will show you a pathway through to 2050. So every building has every building typology has a different pathway bespoke to it, and that's location based on grid decarbonisation of that country as well. And what's interesting with CRREM is they have 2 pathways. One is an energy intensity pathway and one is a carbon pathway, and the debate is which one is going to be important in the future. So a lot of us in the industry at the moment are pushing very hard on energy intensity and using things like energy use intensity targets, because we know we need to reduce our energy consumption in order to allow the grid to go to net zero carbon. But ultimately, we're talking about carbon. And if there is the grid decarbonisation we're seeing, you might not have to do as intense measures. So again, with a lot of clients I'm looking at the moment, they're implementing heat electrification. We're going to heat pumps, we're replacing lighting, putting better lighting controls in, using CO2 heat pumps for hot water. But the big question for most of those landlords is, do they do works to the facade? So they've got buildings which are 10 years old, 20 years old, which are insulated but not well insulated. And the question is, do they need to do those works? And if you look at a CRREM trajectory, in order to hit the energy intensity, they do need to do that work. Whereas if you look at the carbon intensity, they might not have to do that work. So again, it's a risk-based approach. At the moment, a lot of them are being risk averse. They're doing a lot of the measures that are simple to implement, and then making a decision if they're doing significant works to the building to insulate it. So uninsulated elements, they're insulating, but ones that are existing which have an element of insulation, it's up in the air at the moment. It's a big gamble whether they do it, because if they don't do it, they have a risk of stranding. Whereas if the focus and we get the decarbonisation, they might have spent a lot of money which they might not needed to have done. But again, if you're waiting for a silver bullet, it's not going to come. Your assets will be devaluing over time. So there has to be a strategy. What the final strategy is up for question. And you asked what you need to do. As I said, you need to basically be pushing the building whenever you get the opportunity. So if you've got an office, if you're getting vacant possession, or if you've got a retail unit, if you're getting vacant possession, you need to be doing as much works as you can in that unit in order to improve it, because you're probably not going to get it back for another 5, 10, 20 years per time. So that's improving specific fan powers, improving lighting controls, domestic hot water systems. That will get you a long way down those CRREM trajectories. But as I said, if you want to hit the 2040 to 2050 targets, you're going to be needing to do significant fabric improvements in order to hit the energy intensity targets. And that's what a lot of the industry is struggling to work out how they do and when they do that.
Great, thank you. So just jumping to neighbours. So one of the questions is neighbours only applicable to offices at the moment? And I'm going to add my own question to that. If your answer is yes, do you think neighbours will become a mandatory scheme or a replacement for things like EPCs and debts in the future?
So at the moment, Neighbours UK is office only. So you can only get a neighbours rating for an office in the UK, that's base building. In Australia, where it started over a decade ago, Cundall helped set it up. There is also schemes for hotels and retail. They haven't got the momentum that offices have, but there's no reason why you can't use the methodology. So the calculation methodology, which is fairly robust, it's very well aligned to TM54, the advanced simulation. You can still use the design for performance approach on a hotel, a school, a restaurant, a retail, any type of building. You can do advanced HVAC modeling. You can do off-grid scenarios. That's kind of covered in TM54. So Neighbours as a scheme at the moment, as I said, only does commercial offices base building. But if it does what Australia does, it will introduce other typologies. And what they've done in Australia is introduce a neighbours rating for the occupier. So the base build has a rating and the occupier has a rating. Ideally, they're both aligned, so you get the combined benefit. Will it replace EPCs? You have to remember EPCs aren't a prediction of operational energy. They were brought in as a measure of energy efficiency. So a good example of that is if you're just using, there are checks against doing some of these things, but if you're just looking at EPC or Partal assessment, you're looking at the efficiency of the light fitting. So if you've got a light fitting with 100 lumens per circuit watt, you put 2 in a room, it will give you a performance. If you put 4 in the room, it will give you the same performance. Whereas in reality, we know if you've got 4, you're going to use twice as much energy. Same with specific fan powers. Everything's based on minimum ventilation. If you put twice as much air into the building, you're obviously going to use more energy, but Partal EPCs don't care. They're just looking at the efficiency. So EPCs are a good way of looking at the efficiency of the systems within a building. They're not looking at the energy performance, how a building is actually operating. So they'll always, and it's a very easy thing to do. So most, again, I've probably been a bit flippant there, but if you're doing an EPC for an office building, it will probably take you up to a week to model that and get an EPC for a new building. Whereas if you're doing an advanced design for performance or TM54, that might be a 2-month process. So it's a lot more costly, a lot more intense, and you need to have a lot more data in order to do that assessment. So it won't replace EPCs. EPCs will always have a place in terms of compliance, but we need to move away in the industry from just focusing on compliance. We need to do compliance, and the whole industry need to do that compliance piece, but we also need to be looking at real energy and real performance, and that will drive the energy performance down in this country, which we haven't really focused on. Like I've worked in the industry for almost 20 years, and I'd say only over the last kind of 3 to 4 years have we seen a rise in the use of operational energy. I'd still say at least half, if not 70% of projects being designed at the moment aren't doing operational energy assessments, they're just doing compliance.
Interesting, thanks. I'm going to finish on one final question because it relates to embodied carbon, and I think it's interesting. Wind turbines and solar PV have significant embodied carbon. How will this be mitigated?
It's a very good question. We shouldn't be putting wind turbines on buildings. I think we went for a phase of doing that about 10 years ago and proved it doesn't work. So wind turbines should be put where it's windy. And if you're talking about offshore wind turbines, the embodied carbon in an offshore wind turbine is generally repaid within the first few months of its use. Solar PV is an interesting one on buildings because what's interesting is as the grid decarbonizes, their usefulness becomes less and less. So at the moment, the embodied carbon is generally paid back in 2 to 3 years. That will get longer and longer, that payback period over time, and needs to be accounted for in the whole life carbon assessment. So there is still, at the moment, value of putting PV on, and especially with the energy crisis. So a lot of clients were doing it for carbon reasons. Now a lot of clients are looking at it in terms of cost, because the costs of energy have gone through the roof, so there's financial benefits. When we get to a point where the grid is down at 0.05 kilograms of CO2 per kilowatt hour, then you could question the payback of the PV could be close to its life. So would you put it on? It's a debate. My personal feel is if we've got a grid which is mostly wind powered with storage in hydrogen and other elements, then renewables won't be viable for buildings. But I expect for at least the next 5 years, potentially the next 10 years, PV is probably still going to be the right solution where possible. It also enables you to be an energy positive building, which means you're self-sufficient, which also has a number of benefits in terms of grid diversity control and management of the grid. So I still think they have a role to play, but you really need to be thinking about the whole life carbon story and when what's going to be happening in the future. But if you're doing a building tomorrow, I'd still be looking to maximize the PV on the roof. But it's on most buildings where you've got multiple floors in an urban environment, it's only going to do a small proportion. It's not the focus area. Again, a lot of clients jump to how much PV we've got. You should be talking more about demand-driven control, zoning arrangements, mixed mode ventilation, commissioning and controls, because those are going to get you much bigger energy and carbon savings than putting some PV on the roof.
Perfect. Thanks, Simon. Okay, I'm going to stop questions there. We had over 900 people attend, so there's a lot of questions. The presentation will be available on our website. Simon, are you able to share the slides, or are they?
Yeah, that's fine. Yeah,
okay,
no,
so
I'll share those with you.
I'll liaise with Simon and get the slides as well, and I'll add them to when we post on the website. I'll add to the video recording. Simon, thank you very much for today. It's been a great time. I think it's been really interesting, and we'll probably follow up again in a few months when things change. But for now, I'm going to shut the webinar down, and thank you to everybody for coming. Thanks, Simon.
Thank you all. Cheers. Bye.